Hi everyone, myself Bhimeshwar. I am chemistry faculty. I have been teaching the JEE mains and advanced for last 10 years. Today I am going to give a lecture on small organic topic, that is direct and conjugate addition to dienes. So in this, to explain this, I took an example, that is the simplest diene called 1,3 butadiene. It's the simplest conjugated diene. So with HBr, there are two products formed. One is kinetic product, better you say 1,2 addition product and 1,4 addition product. And below 1,2 I wrote kinetic product, and below 1,4 I wrote the thermodynamic product. So before discussing what is kinetic and what is thermodynamic, let us discuss the mechanism, and I give a definition for both. And after this I discuss with the energy profile diagram followed by one more example. Yes, in the mechanism of HBr addition to this conjugated diene, in the slow step H plus attack as a electrophile to give carbocation intermediate. So if you consider this intermediate one, allylic secondary carbocation, which is resonance stabilized, so that it turns to allylic primary carbocation, which is also resonance stabilized. But if you compare relative stability, allylic secondary carbocation more stable compared to allylic primary carbocation, just because of the additional methyl group whose alpha hydrogen also on the other hand stabilizes through hyperconjugation. Now in the first step, Br minus attack takes place. So to give from the via allylic secondary carbocation, the product is 1,2 addition product, whereas via allylic primary carbocation, the Br minus attack produce 1,4 addition product. So students, if you compare the stability between 1,2 and 1,4, by observing this, 1,4 addition product is more stable because it is a di-substituted alkene than 1,2 because it is only mono-substituted alkene product. Now, can define kinetic product. Yes, if the product formed in a reaction is at faster rate and also through more stable intermediate, is said to be kinetic product. Whereas if the product formed in a reaction is more stable but via less stable carbocation intermediate, is said to be thermodynamically controlled product. So thermodynamic product is more stable product but formed via less stable intermediate, but kinetic product is formation is taking place through less stable carbocation intermediate, but it is formed at faster rate. And also students, one thing to be noted, not always 1,2 addition product is kinetic and 1,4 addition is thermodynamic. Sometimes 1,2 addition can be thermodynamic and 1,4 at that time kinetically controlled product. That I explained by taking another example, and before that example I want to explain this mechanism through an energy profile diagram for comparison of activation energy. So according to collision theory, whenever a reaction proceeds at a faster rate, that means it causes or it requires lower activation energy than the other reaction which proceeds at slower rate. So here kinetic product formation, that is product formed at faster rate, means it requires lower activation energy. That means, generally it is major product at lower temperature, or that means if temperature is low, kinetic product is major. On the other hand, thermodynamic product formation takes place via less stable intermediate, so it requires higher activation energy. That means thermodynamic product is predominant or major product only at a higher temperature. So we can distinguish which is major product and which is minor only on temperature basis, because temperature is the major criteria which influences the activation energy of the reaction. So now I am going to draw energy profile diagram for this formation of 1,2 and 1,4. Then after one more example I take to explain. So this is reactor, this is the product for 1,2 addition. Suppose This is the activation energy, whereas for 1,4 there is slightly more activation energy that I used to denote the dotted lines. This is 1,4 addition. This is the activation energy. As I mentioned, this is energy profile diagram. So energy here and reaction progress. So 1,4 addition here in the example previously, that is previous slide, I have shown 1,4 addition is more stable product, so it is thermodynamic product. That's why the energy of the product is lying below the energy of the kinetic product, that is 1,2 I wrote here. And also activation energy for the formation of 1,4 addition, that is thermodynamic product, is more, whereas activation energy for the formation of kinetic product is comparatively low. So this is the energy profile diagram for the formation of 1,2 and 1,4 addition product for the conjugated diene, that is 1,3-butadiene. So in the next slide, I am going to take one more example. As I mentioned that not always 1,2 is kinetic and 1,4 is thermodynamic. So for that purpose I took this example. Right? It is also a diene. It's also a diene. Its IUPAC name is 2,5-dimethyl hexadiene. So 1, 2, 3, 4, and with HBr we are writing the two products. First 1,2 addition. So this is 1,2. Then this is 1,4. So 1, 2, 3, 4. This is not IUPAC numbering. This is 9 students. And this is 1,4 product. So by observing these two product students, it is very clear both are alkenes, but 1,4 here only it is di-substituted alkane, but 1,2 here is a tri-substituted alkane. So as per the definition of thermodynamic product, being a more substituted alkane is more stable, hence 1,2 addition is thermodynamic product in this example, whereas 1,4 addition will be kinetic product. So see the mechanism for this. H plus as usual attack as electrophile in the slow step. So it is secondary carbocation, allylic, resonance stabilized. This is also allylic, but tertiary carbocation is so this allylic, it is secondary, and it is allylic tertiary carbocation. So allylic tertiary is more stable compared to allylic secondary, and in the fast step students, the Br minus attack takes place on the carbocation. So here the product 1,2 addition product, whatever I mentioned, which is whose formation takes place by the attack of Br minus on this carbocation, this will give 1,2, and from the allylic, what is this tertiary carbocation? So it is more stable than allylic secondary carbocation, which is less stable. So why? Because additional methyl groups, how many? 2 methyl groups stabilize the carbocation through hyperconjugation, whereas here only one alpha hydrogen stabilize this allylic secondary carbocation through hyperconjugation. So overall, we can give the conclusion that not always 1,2 is kinetic and also not always 1,4 is thermodynamic. We stick to the definition that in a reaction, if the product formed takes place is at faster rate and through more stable intermediate, that is kinetic. Here it is 1,4 is kinetic because allylic tertiary carbocation are more stable, whereas thermodynamic product, a product obtained in a reaction, is more stable comparatively, but formation through less stable carbocation intermediate. So here 1,2 is thermodynamic product. So this is the example, students, that I convince you that always, not always, 1,2 is kinetic and 1,4 is thermodynamic. Thank you everyone.